In this section, we're going to talk about systems of linear inequalities. So what are we really talking about? Bullet point number one, we're talking about lines. All we're doing is graphing lines. Nothing more difficult. No parabolas, no cubics, no square root functions. Nothing more difficult, just lines. Okay. Second thing we're talking about is an inequality. So in the previous sections, we were talking about systems of equations. So equalities. This one we're going to talk about inequalities. So what are we really talking about? Greater than or equal to, less than or equal to. Those types of functions. So, and then keep in mind, this is a 200 level math course. We're building up to something bigger. This technically is review, but I'm going to treat it like it's not to an extent. So think about what we talked about in the previous chapters was when we had a system of equations and we said, okay, we had one line here, another line here. The solution was at their intersection. Their solution was some ordered pair, which was an x and a y value. Now we're going to have something slightly different. So let's get down to it. Let's get going. Do we remember how to sketch the graph of a line? So I want you to take a second and just try it. Pause the video and say, do you remember how to graph this first line and the second line? Now I'm going to highly recommend, do not put both of them in slope-intercept form. Do not put both of them into the y equals mx plus b form. There should be another method that you should have learned along the way, which would be called the intercept method. If you remember that, great. If you don't remember that, I'm going to run through it really fast. It's not very difficult. You'll probably be able to pick it up with one example, and it's very powerful, and it'll be super helpful. So, if you can, try to solve both of them, graph both of them differently. One using slope-intercept, one of them using intercept method. So pause the video, give it a shot, and then unpause the video. Okay, so hopefully you tried graphing them, and hopefully you remembered. Okay, we are going to sketch an axis. Now notice I'm using the word sketching because in this class it's not going to be tremendously important that you have perfect graphs. It's more about getting an idea of what the picture looks like because we're going to use matrices to actually do the calculations. So the accuracy will occur there. This is just more for a visual reminder. Okay, so I'm going to graph this first one here. This y equals 3x minus 4. Now that's already in slope-intercept form, so I'm going to run with it. I'm going to go ahead and throw this in slope-intercept form and say it has a y-intercept of negative 4 and a slope of 3. So that means we're going to rise 3, run 1. Now we really only need 2 points to draw a line, and especially because we're not trying to be very accurate, we're just trying to get an idea. I'm not going to worry about getting 3 points or anything like that. Okay, the next graph here, I'm going to use intercept method to solve this one. Now, if you don't know what that means, well, what we're going to do is instead of just plotting 2 points at random, I'm going to plot the x-intercept and the y-intercept for my 2 points. And what do I know about those? Well, I know every y-intercept has 0 for x, and I know every x-intercept has 0 for y. So all I do is I just substitute in those values. I substitute in 0. So for the y-intercept, I substitute in 0 for 3x, and that would make the whole thing become 0. And that leaves me with 7y equals 21. And hopefully this is head math for solving, but we just divide by 7, so that would give me y equals 3. So therefore, my y-intercept is 0, 3. Then we repeat that process, but for the x-intercept. So now I'm going to say my y value is 0, so this term just becomes 0. And I'm left with 3x equals 21. So then I solve, divide by 3, and that gives me x equals 7. So now I have my 2 points. So now I'm ready to graph, because that's all we really need to graph a line is 2 points. So I know one is at 0, 3. The other point is at 7, 0. So 1, 2, 3, 4, 5, 6, 7. And we connect the dots as best we can on a computer screen. That wasn't very good, but you guys get the idea. And now we have an idea. We now know my graph intersects at some point around there. I don't know exactly where it is. It looks like it's somewhere between the x values of 1 and 2. But I don't really care. I've got the idea. Because now we're going to go to inequalities. And I apologize, there's a typo. That should have an equal sign under it. It shouldn't be a less than, it should be a less than or equal to. There we go. Okay, so What's the difference? How do you graph an inequality versus a regular equality like we just did? Well, you do the same thing. So I'm totally going to cheat. There we go. So I totally cheated, copied the graph, and now it's the same graph. You graph them the same way. The only difference now is we need to talk about shading, and we need to talk about, okay, remember this was my blue one. This is, whoops, I thought it was still in blue pen. Let me fix that. This is my blue graph. And so now we're going to talk about its shading. And there are all these tricks about the less than is pointing this way, and I don't know. Those never seem to go well when we get a little more deep into this topic. So instead, I like to talk about something called test points. So what I'm going to do is pick any point on the graph. It doesn't matter, or rephrase, on the axes. It doesn't actually I don't want it to be on my blue line. I want it to be off my blue line. So a good point is usually 0, 0. Unless your graph goes through it, it's a good test point. Because now what I'm going to do is substitute in 0, 0 into this equation. So I'd be left with 0 is less than or equal to 0 minus 4. Or aka 0 is less than or equal to negative 4. And we ask ourselves, was our test point of 0, 0, or I just put the green dot right here, was that point, did it make a true statement? Is this true or false? Is 0 less than or equal to negative 4? Well, no, clearly that is false. So what that means is this side of the blue line is not where my solutions are. It gave me a false result, which means the other side is. So I'm going to shade this way. This is my side where I have solutions for my blue line. Now, as for my red line, let's test it with 0, 0. Let's use its test point. So again, that's going to be 0 plus 0 is greater than or equal to 21. So again, 0, 0 is below my red line, and it's giving me a false answer, which means I'm going to shade the other side of the line. So instead of shading down, I'm going to shade up. Okay, so now, because we're doing inequalities, the question is where's our solutions? And the answer is anywhere there's overlap. And usually we represent this by shading. Now, depending on what system you're in, like for example, if your class is using WebAssign, they do it backwards. Instead of shading the solution region, they shade everywhere else. So just look out for that. But if you're in MathAS, for example, they shade the solution area. So just pay attention to what system you're in, and you do it your way, the way that you're comfortable, and your online math homework system, just pay attention to what they're doing. Be careful. Okay, so this is our solution region, which means any answer in here works. Any answer in here will satisfy both equations, and that's the goal. That's the whole idea here. We just want, apologize for that pop-up. We just want to find answers that satisfy both conditions. Where back when we had equalities, there was only one answer that satisfied both because there was no shading. There was no greater than or equal to. It was just, it had to be equal to. So it had to be on the lines. Here, it can be on the lines, or it can be anywhere off the lines in the direction we're shading. So first thing, what is a solution region? What does that vocabulary word mean? It's the set of all possible solutions. Okay, so it doesn't mean you have to write down some list for all the solutions. It's more just understanding where it's possible to have one. Okay, now the next fun part of this is going to be talking about corner points. Corner points are extremely important, and they are exactly what they sound like they are. These are the corners of your solution region. So the question I have for you is, how do you find the corner of your solution region? Well, if you think back, isn't that what we were doing in chapter 3 with the systems of equations, when we were solving using elimination technique, substitution technique, reduced echelon form in the calculator. Then we went to the inverse matrices. Guess what? We're actually going to have a use for it now. So your job is to use one of your old techniques to finding this corner point. Well, sometimes that causes students a challenge. because they say I don't have equals anymore. I have less than or equal to and greater than equal to. How do I do that? Well, it's simple. You just ignore those. You make them equal signs. You think of them like this. Because, yes, our graph had all this stuff shaded in, but we don't care. Right now, the problem's only asking for the corner points, so that's all we're going to worry about. So I'm going to take my system of inequalities, change them into a system of equalities, and solve it like a chapter 3 point whatever problem. It's your call, or whatever your book is using, whatever chapter that was from. You're just going to find that corner. Okay, next, is this system bounded? Well, what does bounded mean? To be bound means to be restricted, to be tied up, to be whatever verbiage you want to use. The way I like to think of it is, if I were to put my pet cow in my shaded region, would I know where it would be in the morning, or could it have wandered away? And yes, I do not have a pet cow. Just had to clear that up. So this region is not bounded. The one up above would not be bounded because it is not contained on all four sides. And it doesn't have to have four sides. It can have as many sides as you want. But a bounded region might have to look something like this. And then if this was your solution region in here, then you would say it is bounded. But the one up above was definitely not bounded because it didn't have this restriction on the side back here. Okay, that'll take care of us for this first video. So please continue on to the next if you are ready.